Welcome to Module 2 of Machine Learning Fundamentals, a beginner's guide. In this segment, you'll immerse yourself in the essential process of supervised learning. Supervised learning is a type of machine learning where an algorithm learns from labeled training data, helping you predict outcomes for unforeseen data. Within supervised learning, classification tasks are where the output variable is a category. What is classification? Classification involves assigning a category or class to input data. Imagine a simple example, determining whether an email is spam or not spam. Each input email is one instance that the classification algorithm will learn to classify. Let's understand the key classification algorithms. Decision trees. Decision trees are a set of rules used to classify data into categories. They split a data set into smaller subsets while at the same time, an associated decision tree is incrementally developed. Random forests. This is a collection or ensemble of decision trees where each tree is slightly different from the others. This method combines the output of multiple trees to make a final decision, improving the classification accuracy. Support vector machines, or SVM. SVM is a powerful classification technique that works by finding a hyperplane that best divides a dataset into classes. Let's understand the difference between decision trees and random forests. A decision tree has a flowchart-like structure where each internal node represents a test on an attribute, each branch represents the outcome of the test, and each leaf node represents a class label. How it works? It begins with the original set, splits the data based on an attribute that results in the largest information gain, or highest purity, and repeats this recursively. Random forests utilizes multiple decision trees to improve classification accuracy. Each tree in the forest is built from a sample drawn with replacement, also known as a bootstrap sample, from the training set. When splitting each node during the construction of trees, the best split is chosen from a random subset of the features. Alright, let's talk about the advantages and disadvantages of decision trees and random forests. Advantages and disadvantages. Advantages. Decision trees are simple to understand and visualize. They are pretty straightforward, making them accessible to many people. Random forests, on the other hand, correct for decision trees' habit of overfitting to their training set. This makes them more robust and reliable. Disadvantages. However, decision trees can create overly complex trees that do not generalize well from the training data. They can become too intricate and specific. Random forests are usually slow in generating predictions because they involve multiple decision trees. This can make them less efficient in real-time applications. Now let's move on to support vector machines, often referred to as SVM. SVMs work by plotting each data item as a point in n-dimensional space, where n is the number of features. The value of each feature corresponds to a particular coordinate in this space. Then SVM performs classification by finding the hyperplane that best differentiates the two classes. This hyperplane acts as a decision boundary, separating the data points into different categories based on their features. The kernel trick can transform an input space into the required form by making it possible to perform linear classification in a transformed version of the input space. Common kernels include linear, polynomial, and radial basis function, or RBF. Let's talk about the advantages and disadvantages of support vector machines, or SVMs. First, the advantages. SVMs are effective in high-dimensional spaces, which is really useful. They are also memory efficient, as they use a subset of training points in the decision function. Now, onto the disadvantages. SVMs are not suitable for large data sets because the training time can be quite high. Additionally, they are less effective on noisier data sets with overlapping classes. Steps to use Python and scikit-learn library to build a simple classifier using the SVM method. Step 1. Load data. Start by loading a dataset. You can use datasets like the iris dataset provided by scikit-learn. Step 2. Pre-process data. Split the dataset into a training set and a testing set. Step 3. Train classifier. Implement a SVM classifier using scikit-learn. Step 4. Evaluate your model. Use accuracy_score to measure the performance of your model on the test data. And now that you understand the basics of several classification models, remember that practice is key in mastering these concepts. It is advised that you explore different aspects of each algorithm, experiment with different parameters, and see how your model's performance varies. Also, consider trying out other classification algorithms and datasets to broaden your understanding. Thank you so much for taking the time to watch this online training module. I hope you found it valuable and insightful. To stay updated on upcoming content, including new modules, case studies, and quizzes, be sure to subscribe to my channel and share in your community. Your support helps me create more content that enhances your learning experience. Don't miss out on the next steps to watch other module videos to deepen your understanding and apply the concepts in real-world scenarios. Thanks again, and I look forward to seeing you in the next video.